We have the data in Postgres database that contains all of our movies and the corresponding vector embeddings which were generated by TensorFlow. In this video, we'll request recommendations from within the API side of our Next.js project. As always, the link to the detailed guide is in the description below. Also, leave any questions or suggestions you have in the comment section. Anything you're struggling with or anything you would do differently. But let's jump into the code, and because we are using TypeScript, let's add a declaration file that contains type information for a movie. For this, we will add a new file into the project and we will call it movie.d.ts. And here we will add the declaration for the movie type. I'm going to copy it from the accompanying article. Again, typos are evil and I don't want to type everything here. So again, the link you will find below if you need that reference. And I will just press copy the complete declaration. We put it into this file and we are ready. So it's pretty simple. We could have lived without it, but why not? Next, what we are going to do is to create a new API route. The API routes, which call external API endpoints, are located in pages. There you will find API folder and there we already have hello.ts. This is where we need to locate to put our own API route, which we will call recommendations. To make it simple, we just rename the existing example to the recommendations.ts and we will clean everything which we don't need to have there. Now if we go inside, it just returns some John Doe stuff and we don't really need that type. We will have our own, so I'll clean that. And as well for the response, we don't really need that type over there. To start our project, we need to run npm run dev if you haven't done it yet. And this will allow us to go to localhost 3000. And since we renamed hello to recommendation, the endpoint localhost 3000 API hello no longer exists. So if we try to refresh it, we should get 404 error. However, if we are requesting recommendations, we do see that object being returned, so everything is working, at least for now. I would need a bit more space, and I don't think we will really need any more the terminal. So let me remove that. So this is our basic API route, and this is how it looks. So we will need to do something similar, however, in regards to our recommendations. And again, we are going to work with TensorFlow and with Postgres. So I'm going to copy the dependencies which we will need, which we installed in the previous video. If you missed that, you will find the link above. I'm also going to copy here the configuration to access our Postgres database with all the properties which are necessary to establish the connection. We have seen this already in the past chapters. And similarly to how we have done it in the past, we are going to load the model, or almost similarly, because I'm going to use here await, since we can make our handler function async. So we can do it right now so that we can use await over here. And then once the model is loaded, we can request the embeddings from TensorFlow. And we need to use the model embed function and provide our input line, either an array of strings or a single string. So we are going to get a single string from the front end. So this is what our user will be entering and what we are going to convert into the embeddings. However, we don't have front end yet. So let me just cover this and comment it out, and we will use just an example string. Again, as in the past video, we are going to look for a lot of cute puppies. After that, we can do a racing on the embeddings request to retrieve the embeddings, and we are interested in the first one since we only have a single string. And next, we are going to connect to Postgres. For this, we will initialize a client, and we need to run the connect function. Now we are ready to send that query to Postgres, where we will ask to get the movies which are closest to the provided embedding. So it will look like this. We will select everything from our movie plots, but we will order the results by how the embedding property from the movie plot is close, and it uses L2 distance, is close to the embedding which we got generated from the string lots of cute puppies. So we compare there because we need to put it into a variable, and also we need to do the JSON stringify on top of this, and I made typo, of course. So we do JSON stringify. And let's also limit this to just 5 values. We will get the 5 closest items to a movie with a lot of cute puppies. Assuming that will go well, the response from PG request we need to retrieve back and return to the front end. So this will be the JSON body which we are going to return. So it will be the value, the rows from the response. Oh yes, it should be response, PG response, not the request. So it will be PG response, rows, and we will print those back via the API call. We will need to catch all the errors which may happen while we are doing that, and also output those. And finally, close the connection with the Postgres database. And now, if we go back to the browser and we run the request, we should get not an error. Okay, I think it's an easy one. I missed a dot over there, so the path should be to the root path of our project. So now it should be working, and we should, yes, we got not so friendly yet list of the movies, and again we got some movie about Labrador and some other movies. So we succeeded in creating an API which returns us recommendations for a single string. Yet the string we still embedded manually. Next step would be to create a front end so that we can use this API route, and we can send the request body search property to here, and we will use that one to convert into an embedding and request nearest neighbors from a Postgres database using PGVector. We'll do it in the next video. See you there.